Welcome everyone. The title of today's notes is Systems of Inequalities. And this represents really just a prerequisite for the following lesson where we will be looking at applications of these inequalities, what is actually called linear programming. So you'll see probably a lot of review from Algebra 1 here, and the expectation is really that we just perfect and solidify some of those skills from Algebra 1 so it allows us to move forward. So let's go right in. We've been talking a lot about systems of equations. Systems of inequalities will be represented in a quite different manner. So let's see what that entails. So here we go. Systems of inequalities very simply would be a collection, and let me get this down for you, a collection of two or more inequalities. Okay, so we've seen systems before, worked with all types of systems of equations. What's going to be different really is the solution to the system. If you remember correctly, when we looked at systems of linear equations, well really for the most part we just got one solution, one ordered pair. When we looked at systems of nonlinear equations, we potentially got more than one ordered pair, but definitely a finite number. Here, everyone, when we look at a system of inequalities and we look at the solution set, it's really going to be an infinite number of ordered pairs. And so we're going to have to figure out a way to represent that. So let's, on your paper here, it says solution to the system. Obviously, in a very similar way at least, it's the values of the variables that make each inequality true. Now, how is that going to be represented? How do you represent an infinite number of values, as I alluded to? Well, basically, we're going to be doing this graphically. And so here's what I'm going to write on my board, and you write on the paper. It's going to be represented as what we would call a solution region on the coordinate plane. So not sure if you remember from Algebra 1, kind of shading on the coordinate plane. Well, that's exactly what we're going to do here today. So what we're going to do is graph the boundary line, kind of separating the coordinate plane between the values that would work and the values that don't work. And we're going to shade for the values that do work. So there are a couple guidelines here for graphing these inequalities, and we'll kind of go through that process and then just try a few examples here today. So number one, it says replace the inequality symbol temporarily, of course, with just an equal symbol and graph the boundary line. And so what we want to do, as I said, is kind of divide up the coordinate plane between the ones that work and the ones that don't work. And the boundary line will do exactly that. If you remember correctly, we do a dotted line for these two inequality symbols, less than or greater than. So that would sort of represent everything up to, but not including the values on that line. So that's how we would represent that visually. And then a solid line would be the or equals piece, so less than or equal or greater than or equal. And that's how we would sort of represent the fact that everything up to and including the values on that boundary line. So dotted if it's not equal, solid if it is equal. Now there are a couple ways to pull this off. We're going to do it this way as it says on your paper. We're going to test a point on the coordinate plane and see if it works in the inequality. If it works, then we shade the region with the point. So basically that point will be representative of the entire region on the coordinate plane, either above the line or below the line, just depending on where we select. So if it works, then everything in that region is going to work. If it doesn't work, then nothing in that region will work, and the other side of the line would work. And so we want to shade the region without the point. And that's what I'm going to write in here. So shade the region, in this case, without the point. So if you're still not sure, solid versus dotted, shading with, shading without, don't worry about it too much here. As we go through the process, it'll all start to click. But make sure you have those pieces in place here as we move forward. So those are the guidelines. The best thing, of course, to do is to try it out with a couple examples here. I'll kind of show you the way we'll go through this process, especially with a couple of these inequalities, these linear inequalities, kind of written in that standard form. It's definitely not in slope-intercept form. So we're going to graph it a very particular way. In fact, when we do the applications coming up in the near future here, you will see that most of them will be represented this way as well. So excuse me, it's a good way for us to kind of get our bearings on it and see what we're going to do. Okay, well, let's go for it here. It says graph the system of inequalities, and let's just take a look at two of them. And so right away, I would start with just the boundary line. Again, you don't have to write that if you don't want to, but that would be the boundary line separating really the points that will work in the inequality from the points that don't work in the inequality. And we're going to graph this on the coordinate plane, and we're going to basically do this using intercepts. So what we're going to do is find the x-intercept of this graph and the y-intercept of this graph, and then we're going to graph the line. So here's how it plays out, everyone. I'm going to do the x-intercept first, and I think we all know that on any x-intercept, the y value happens to be 0. And so one way to kind of look at this, and if I was standing in front of a class, I would literally cover it up with my hand, but basically we're going to make the y value 0 here. So in essence, everybody, this goes away. So, basically I cover it up, and when I cover that up, I just end up getting 4x equals 8, and so I end up getting x equals 2. So one of the points on that boundary line, very quickly, is just 2, 0. The x-intercept is 2. And so when you get an opportunity here, everyone, can you give me a point right at 2, 0? So again, hold your hand over the y term and solve for x. Now, when I reverse the process, I'm going to find the y-intercept here. Basically, I'm going to cover up the x term. So put your hand literally over the 4x, and if you put your hand over that 4x, you end up getting this piece right here, which means if I solve for y, divide by -1, again, on the y-intercept, the x value is 0. So what would happen here, everyone, is I would get this as 0 and -8. And so you can see just very quickly by that cover-up, x-intercept and y-intercept, you end up getting 2 nice points on the line pretty quickly. So let me just make sure, 2, 4, 6, and 8 down at the bottom here. Now, how many points do we need to know what a line looks like? Only 2, of course. And so I have 2 points pretty quickly here just by finding those 2 intercepts, and now I'm going to draw a line between them. And so in this case, we have to ask ourselves, is it a solid line or a dotted line? And go to the symbol, and it looks like it is a solid line right there because of the or equals. And so let's go ahead and draw a line going through those points. Something like that would do. And so what we want to do is include all of the points on the line. They would actually work because they would make the or equals part of that symbol. But now we want the other symbol, and so here's how it plays out. We're going to test a point on the coordinate plane. And I would argue that the easiest point to test, if it's available, is probably right smack in the middle there at the origin. So if x is 0 and y is 0, would it make the inequality true? So I would go right over here, and I would actually do this. And again, you're probably able to kind of just do this mentally. But basically, I'm going to put in 0, 0 into the inequality. 4 times 0 minus 0. Is that less than or equal to 8? Well, sure. It's definitely less than 8, and so it fits that inequality. It makes the mathematical sentence true. So here's how it plays out. If this point makes it true, then all of the points above this line, all of them right in here, are going to also make it true. This is representative of the entire region. And so what we're going to do is shade, because as we said, kind of an infinite number of solutions here. Now, I can't do it lightly on mine, but just very, very lightly on yours. Go ahead and sketch that out. All of the points above that line would make that inequality true. Okay, good. 1 down, 1 to go. So let's take a look at that next piece. I have 2x plus 3y equals 6. Let's do the cover up, everybody. So what you're going to do is cover up the y term, and you get 2x equals 6. And so very quickly there, you just get 3, 0. And then same deal, to get the y-intercept, I cover up the x. That kind of goes away, and I get 3y equals 6. And I get 0, 2. And so now I have 2 pieces there. it looks like an x-intercept of 3, everyone. So when you get a chance, x-intercept of 3, and a y-intercept of positive 2. So it looks like right up there. And then we have to ask ourselves, of course, do we want to draw a solid line or a dotted line through those 2 points? And in this case, again, look at the symbol, no or equals here. So I believe we want to go ahead and draw a dotted line, right on through. And that looks excellent. So now again, you can see we've divvied up the coordinate plane into 2 parts, kind of above that dotted line and below it. One of those parts, everything's going to work. One of those parts, nothing will work. So I would argue that we should be testing that 0, 0 one more time. So that is below the dotted line. Let's test it and see if it works. So I have 2 times 0 plus 3 times 0 greater than 6. And if you get this, you see that 0 greater than 6, that doesn't make any sense. So in this case, 0 is not greater than 6, so this point, unfortunately, does not work, and so only above the line would work. Now, just for the first time, I'm going to kind of shade it everything above that dotted line. As we get more and more into this, you'll start to see we don't need to do that. But basically, I would shade above that line like I have. You do the same very lightly, and you should see an area in the coordinate plane where the 2 shaded regions overlap. And that should be, follow my pen here everybody, should be in this region right in here. And as a result, that would be the solution to the system. So once you see that solution, or that region I should say, once you see that region, then you want to probably go ahead and darken it in nice and deep. And that's how we represent it, the infinite number of points in this area right here. All of those would work. I can put anything in any ordered pair in this region back into the system of inequalities, and it would make, in this case, both of them true. So that's how it's going to play out. We're going to move on to example 2 here, but if you're not sure of something, obviously, please let me know, put a question mark by it, and certainly ask. All right, number 2. So example 2, same rules. In this case, we have 4 inequalities, and this just happens to be one that we're going to see on the next lesson here when we start to do some of these applications. So you can highlight it or not, it's totally up to you. But that's one that's going to come up quite a bit, so why don't we talk about that piece, and then we can kind of move forward with the other 2. So when I see something that says x is greater than or equal to 0 and y is greater than or equal to 0, that kind of leads me to believe that really our solution region is going to end up in only one of the 4 quadrants that you see on the coordinate plane here. And if you could think about this, I'm going to just do this without really drawing it, but x equals 0 as a line, remember x equals a number is a vertical line, so x equals 0 happens to be this, y equals 0 happens to be this, the x-axis, and if they're both greater than, I believe, everyone, that we're really just focused up in the first quadrant. So if x and y are both greater than or equal to 0, that can only be up here, where they're positive. So when all said and done, in terms of the shading, everybody, even though I might have values that are negative that work in here, I don't think we necessarily want them because of the prerequisites up here. This says, you know what, just shade up in the first quadrant there. And you will see really all of our applications beginning on the next notes worksheet will follow that suit. Basically, we're just going to make a coordinate plane only utilizing the first quadrant. So that's where our shading will be. Well, let's give it a try, of course. I'm going to go with the 3x plus y equals 6. And again, if you don't feel like you need to write some of this stuff down, that's fine. But I'll go ahead and do that and just make sure we're all on the same page. So x-intercept first, cover that up with your hand, everybody, and you get 3x equals 6. So 2 comma 0 definitely is the x-intercept. So everyone, when you get an opportunity, put a little 2 comma 0 right in there. Now guys, cover up, if you would, the x term, and you end up getting just y equals 6. So again, nice and easy there. Quick as can be. 2, 4, and 6. And that's looking pretty good. Now, again, theoretically, there is a line that's going through those 2 points. Let me see if I can get this decent. Theoretically, we should test a point, and so let's test that point out. I'm going to test 0, 0, which is definitely below the line there. So I would do 3 times 0 plus 0 less than or equal to 6. And that looks like a true statement there, a little check mark by it. So 0, 0 definitely does work. And so remember what that means basically. We would shade all below the line here, everything below. But here's what we, I guess, kind of figured out. I had talked about this piece right up here. Remember, we're really only shading in the first quadrant. X and Y are both greater than or equal to 0. So in reality, and again, I'm going to try to do this light. It's just tough for me to do this with this pen, but just very lightly, let's shade up in the first quadrant. Here's the boundary line x equals 0. Here's the boundary line y equals 0, and we end up getting that piece right there. It looks really nice. Well, let's also do this next one here. So I get 2x plus y equals 2. Same deal, everyone. Let's get a groove on this. Cover that up. You get 2x equals 2. And so I get 1 comma 0 there. And I'll put that in momentarily. And then cover up everybody the x term. And we end up getting just y is equal to 2. And so very nicely there, 0 comma 2 would do it as well. So let's see what works here. I get 1 comma 0, 0 comma 2. It looks like a solid line going right on through. And I'm just curious about, oh, never mind. Okay. Something like that would do. Again, not too concerned about that. And let's test the point, everybody. So here's my boundary line. I need to know if I'm going to shade below it or above it. And let's see what unfolds here. So I'm going to test that 0, 0. It's just a good one to test. If it's not on the line, I would definitely recommend doing that. So 2 times 0 plus the 0 and greater than or equal to 2. Is that true? And let's see. No, 0 is not greater than or equal to 2. Not going to work. So we're not going to shade below the line where the 0, 0 is, everybody. It's on the other side there. Now, again, officially, I would be shading all above that line, every single point above that line. In this case, I'm already sort of constrained in here, I believe, from the other 3 inequalities. And so I'm seeing above that line, below that first one, and in the first quadrant, it looks like it is somewhere in there. And so in terms of solution region, I think that's it. We've got a nice little polygonal figure. In fact, we're going to see that coming up on the next lesson. One thing that will come up, not that we need it here, everyone, this is our answer right in here, represented visually. But one of the things we're going to have to find, everybody, would be the vertices on such a polygonal region. So could you tell me what that vertex is? Could you tell me what that vertex is, and that vertex, and that vertex? And that's what we're going to start to see on the next one. All righty. Good, good, good. Let's go on to the last one. So this is a good one right here. Just a nice application, dealing with systems of inequality. So I'll read through it, and then we'll graph it and get underway. So it says, for people between ages 10 and 70, the target zone for aerobic exercise is given by a system of 4 inequalities there. A is the person's age, and P is the pulse rate. So basically, there's going to be this target zone for people between ages 10 and 70 to get their pulse rate. Obviously, you can kind of consider this. You need to get the pulse rate. There's probably a minimum for a pulse rate there, so you're getting some type of cardio work. And there's probably a maximum also for the pulse rate, just because you obviously don't want your pulse rate to get too high. And so let's see what that would look like on the coordinate plane, everyone. So we're going to graph this momentarily. Let me just take a look and see what we want to do with this. I guess I would kind of argue that the pulse rate would be dependent on the age. So everyone, it looks like age is going to be the independent variable, which will be the x. So guys, how about you give me a little a right down there on the x. And then as a result, p would be the dependent variable. So why don't we throw a p coming up there. And this will be pulse rate in terms of age, I suppose. And let's see how we want to do this. I'm not sure how we're going to want to scale this out here. Everyone throw a little 0 in if you don't mind. And then let's see, I'm just going to count out here a little bit just to see how many I have on my grid. And it's the grid I gave you. It might not be ideal, but we'll see how it works. So 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16. Okay, not too bad. I think I'm going to go by 20s going up here. Again, if you choose something different, obviously I'm just doing this on the fly. So if you end up with something different there, that's great. You know, think it out. You can certainly pause the video, take a look at a couple of the numbers there and see what might work for you. But I'm going to go by 20s at least now and see what happens. I'm going to try to go up to 240 there. Hope for the best. And, you know, to be honest, it looks like I'll probably go by 20s here. Probably could go a little more. So 20, 40. Nothing written in stone about this, by the way, everyone. You know, you choose your own scale. I would argue you probably want to go by the same amount, though. So 160. And I'll get up there. You guys do the same on yours, however you want to do it. As I said, nothing really that's required here. All right, well, let's see what we have going. I think I will do the top two. No, you know what? Let's do the bottom two first, just kind of looking at that piece. So let's do those, and then we'll kind of sketch this out and see what it looks like. So if you don't mind, I'm going to reverse the order. I'm going to do these two right here. Then I'm going to go back and do these two up here. I think I want to set a couple of these boundaries up just from those easy ones. And then, again, we'll see what happens. But same deal, everyone. What I'm going to do is just graph 4 boundary lines and shade appropriately. So let's take a look, everyone. I'm going to just work over here in terms of the boundary lines. Boundary line is A equals 10. Again, sort of the independent variable equaling 10. Now, don't write this on your paper, but I guess I kind of think about it as if it's the independent variable, it's x equals 10. And as we do all know, of course, x equals a particular number forms a vertical line on the coordinate plane. So what I would do, personally, is come over to the x-intercept, go over to positive 10, and it seems like this is going to be a vertical line coming up this way. Something like that. And again, now I do want to apply a value here. I think we can look at this one and maybe make a good educated guess as to what happened. We want ages greater than or equal to 10. So in this case, it's not above or below. It's really left or right. And I'm hoping you would all agree that it's going to be to the right there. So as a matter of fact, I'm going to hold off on shading, just kind of knowing that it is off to the right. We'll kind of get into that piece as we go through the process. But I would say it's to the right of that vertical line. Okay. And then let's do the other one, everybody. So the next one, it has to be less than or equal to 70. Same deal, as you can all see. You know, just think of this as x equals 70 in terms of what it would look like on the coordinate plane. And that should be another vertical line. And so everybody, what I would do in this case is go over to 70 on the x-axis. And let's go ahead and do a vertical line there. And so this model is good between ages 10 and 70. In this case, again, it sort of says less than or equal to 70 for the ages. So do we shade to the right or do we shade to the left? And I'm hoping you would agree that basically right now we're talking in there. Now you are more than welcome. Again, it's hard for me to shade lightly. If I had a pencil here rather than this pen, I would shade this just extremely lightly on your paper. And just so you can kind of see that's where we're headed. I'm going to leave it blank for now and then start to fill in a little bit. Okay, well, let's go get the other two. So now starting at the top, here's my boundary line, everybody. So 2a, 3p, and equals 450. Here we go, guys. Do the cover up. So we want the a intercept. So cover up that 3p term, and you get 2a equals 450. And so I'm getting a 225 on that. And so when a is 225, the pulse rate is 0 there. So let's see. Actually, I'll hold off just a sec, and I'll do the other one. Okay, everyone, let's get the p intercept. So cover that up with your hand, everyone. Cover up the 2a, and you get 3p equals 450. Everyone divide by 3, and oops, we end up getting, it looks like when a is 0, it looks like we end up getting 150. All right, well, let's go ahead and graph those two, and let's see what this looks like. So 225, 0, I'm going to have to ballpark that one, but probably right in there. give or take. And then 150 I think I saw, so 150 on the y-axis. There we go, looking good. Right in there would do. Not going to be ideal, but let's see if we can go ahead and straighten those out. By the way, when we do the next lesson, I'll probably ask you to have a ruler handy. We might need it to do a couple things. But in this case, I don't think it's quite as necessary. Okay, well, let's see. I needed to check a point. Let's go over to the coordinate plane, everyone. 0, 0 is a great one to check. It is below the line that I drew. Here it is. Here's the line. And 0, 0 is definitely below it. So am I going to shade below the line, or am I going to shade above the line? Let's test that 0, 0 to see. And so in this case, I got 2 times 0, 3 times 0. And is that greater than or equal to 450? And I think the argument can be made that, nope, that's not going to happen. So 0 is not greater than 450. So as a result, everybody, it looks like I would be shading above. So guys, now start to wind it down a little bit. I'm just going to sort of show you what the shade would look like. Again, just a little, every time you come up with another inequality, just a little darker, a little deeper. There's still one more to be had there, and then we'll really shade it in properly. But I think I'm up here. All right, last one. Let's go get this one right here. I've got A plus P equals 190 as the boundary line. And cover up, guys, and in this case, it looks like each intercept, I'm hoping you kind of see this, each intercept, if I do a cover up, looks to be 190. So 190 comma 0 and 0 comma 190. So let's come over one last time there. Everyone, here is 190 comma 0. Here is 0 comma 190. And when you get an opportunity, everybody, let's close that on out there. Let's see, I'm going to come up from this end, get something like this. Oh, I missed it. There we go. Not too bad. Could have been better, could have been worse. Tough to draw straight lines up on this board there without a ruler. Again, if you can kind of pull that off, that would be great. If not, no big deal. Okay, so let's see. Let's put in the 0, 0 again. That 0, 0 is below the line. And so I got 0 plus that 0, less than or equal to 190. And absolutely, that certainly works. So 0 is less than or equal to 190. So let's see, here's the line right here, everyone. And so as I kind of look at my region, did we want to shade above it or below it? And because 0, 0 works, everyone, we want to shade below. And so I'm getting a solution region just like that. And think about this. If you were to visualize target pulse rate for people between ages 10 and 70, would this be a region that would, you would sort of envision? I would think so. So when you're young, obviously, pulse rate can get a little higher. As you get older, obviously you don't want your pulse rate to get too high. And yeah, this looks great. It decreases over time, both the maximum and the minimum pulse rate for each age. Okay, so at the time of this particular posting here, I'm 41. So the question, of course, is for letter B. Me being 41 years old, am I able to get my pulse rate up to 158 and feel pretty good about it? Let's take a look. So here's 41, everybody. Is that one of the infinite number of ordered pairs there? So 140 and 158. Looks like it's kind of towards the high end of this. Tough to tell. I didn't do the best job, but I would say it's there. I'm going to put a yes. If you guys come up with a no on that, let me know. It would be interesting to see. It's tough for me to tell because I didn't do such a great job visually with this. Maybe you did a slightly better job. But I'm seeing 41 and 158 kind of right in there. I guess we should kind of see if it works in one of the equations in one of those boundary lines. But rather than kind of diving deeper in, I'm going to put a yes and move on. Okay, how about this? How about for a 16-year-old? So somebody in your age bracket there, could you get it up a little higher there at 163 without too many issues? Well, let's take a look, everyone. So 16 would be, right in here, give or take. Move it on up, 163. And yeah, that's well within your region. So again, there are an infinite number of points here. and you can kind of see the relationship between age and pulse rate. This would be the target zone for getting any type of aerobic exercise. Okay, as I mentioned, just these are the skills that we're going to be utilizing with some applications coming up on the next lesson. So please just make sure you're really comfortable shading in the appropriate spot and really coming up with your solution region appropriately. And as I mentioned, the next step is really to start talking about these vertices here and then utilizing them. All right, well, in the meantime, if you have any questions, you'll of course let me know. And as always, thank you very much for listening.